All right, so we're going to start off with a couple more vocabulary terms. Okay, and you might find that this is pretty simple, but it's a good reminder. Okay, so positive numbers. Can anyone tell me what is a positive number?
Number that's not negative.
That's true. What else do we know about positive numbers?
Number 1, 2, 1.
Okay, so what do we know about those numbers? What makes them positive? No, not necessarily.
Not negative.
Okay, but because they're not negative, what are they?
Well, positive. Regular numbers. They're optimistic.
They're greater than 0. Okay, positive numbers are numbers that are greater than 0. Okay, positive numbers are numbers that are greater than 0. Okay, so negative numbers. Anyone want to take a shot at this definition? Yeah, they're going to be numbers that are less than 0. Okay, so what would 16 be? What about 37? What about, well, it's kind of a giveaway, -2. Yeah. Okay, so let's look at some examples of how we see positive and negative numbers in the real world. Okay, so we're going to look at a few examples. Okay, so the first one, talking about a gain of 20 yards in football. A gain of 20 yards in football. Is that going to be a positive or negative? What would a number be that we could use to represent that? A gain of 20 yards. Yeah, positive 20. Or plus 20. What about, this one's a little tricky. Spending $75. Think about related to like your money. If you spend $75, yeah, you are losing or getting rid of $75. Okay, what about 10 feet below sea level?
Negative.
What number could we use to represent that?
Negative.
Yeah, it would be -10. Because it's 10 feet below sea level. Can anyone think of any other examples that you've heard of or seen before? Nothing?
20 inches under the earth.
20 inches under the ground? Sure. Sure. Like you've eaten 2 pieces of pizza out of a whole pizza, so you're down 2 pieces.
$30
$30 in debt. Yeah. Anybody else? Okay, those are good examples. All right, so that should be very simple, very familiar. We know the difference between positive and negative numbers, but it's good to get a reminder. Put some feet down. Okay, so let's look at a couple more terms. These are the last 2 terms that we're going to look at today. Okay, so not a lot. Okay, the first one, integers. Anybody tell me what integers are? No. Mm-mm. Well, they could be. Yeah, so integers are just the set of all whole numbers and their opposites. So any number, any whole number from, any number really, and its opposite. So would 1/2 be an integer? No, because why? It's not a whole number. So the key thing to remember is that integers are whole numbers. So integers are the set of all whole numbers and their opposites. Like that would not be an integer. Fractions would not be, I guess decimals, certain decimals would not be. Repeating decimals for sure would not be. It's got to be whole numbers. Just if you were to count 1 to infinity by even numbers. Would 1.5 be an integer? No. So it's not a whole number. It's in between 1 and 2. Hmm?
So, like if you have the whole number 15, then it becomes automatically -50.
Its opposite would be -50. So 50 and -50 are both going to be integers.
How is that hard? Like where you, like it could be 7, 6, and then it says like pound and then you like go to fractions and 6, 7.
Fractions can't be integers. Okay?
No, like where you like put them in.
No, it's different. When we're talking about opposites, we're just talking about positive or negative. Okay? So, the next term we're going to look at is absolute value. Raise your hand if you've heard the term absolute value before. Okay, this might be new for some of you. So when we're talking about absolute value, it's basically, if you can think of a number line, and you know zero's in the middle, what's going to be on the left of the 0? Negative numbers, right? What about the right of the 0? Okay? So when we're talking about absolute value, we're talking about the distance from a number, from an integer to 0 on the number line. Okay? So absolute value is the distance from an integer. And you know integers can be positive or negative as long as they're whole numbers. Oops. The distance from an integer to 0 on a number line. So you can kind of think of it as how far away from 0 is this number. That's its absolute value. So let's first make sure that we can correctly identify and graph integers and their opposites, okay? So for this first one, we've got -4. You need to draw yourself a little number line. Okay, and we know that in the middle of the number line is going to be what? 0. Everything to the right is going to be what? Positive. What about everything to the left? Yeah, these are all going to be negative. Okay, so if I were to graph -4 on the number line, where would I put it? On the -4. Now what about the opposite of -4? What would that be? That would be +4. Okay? So we've got -4 and +4. That's what they would look like on the number line. It's the same, they're going to have, and we'll see this in a minute, but they'll have the same absolute value because they're both the same distance from 0. I'm not sure. We'll have to look at it. All right, let's look at another one. +3. Okay, we can start by labeling our number line. So I'm going to have positive on the right and negative on the left. So where am I going to plot 3?
On the
+3. So what would the opposite of +3 be, Crystal? -3. Okay? And we can see that they're the same distance from 0, both the positive and the -3. Zero is just 0. I don't think it's classified as either positive or negative. It's just 0. Right in the middle. Okay? So, you must have been reading my mind. So if we're looking at 0, we know that it's right in the middle. We've got positive on the right, negative on the left. So if we were to plot 0, where would we put it?
At 0.
Right in the middle at 0? Does 0 have an opposite?
No.
No, 0 is just 0. It is, and its distance from 0 is 0 because it's on the 0. Okay? Okay, so what if I asked you, what is the opposite of 16?
-16.
What if I asked you, what's the opposite of -50?
50.
It'd be +50. Okay? Now, -50 and +50, are they going to be the same or different distances from 0? They'll be the same. So their absolute value will be the same. Okay? We're going to look at that next. All right, so the next thing we're going to do is we're going to practice finding the absolute value. Now, when you see an absolute value problem, it's going to have the number written inside these long bars. Okay, they kind of look like ones, but they're just these bars, and those signify absolute value. Okay, so this example, the absolute value of 1, it's asking how far away is, or negative 1, how far away is negative 1 from 0?
1.
It's just 1. So the absolute value of negative 1 would be 1. Then we've got the absolute value of 4. How far away is 4 from 0?
Negative 1.
How far away is 4 from 0?
4.
Just 4, right? Because we can count, or we could do jumps on the number line. We would go 4 times to get to 4. So the absolute value of 4 is going to be 4. Okay? So let's look at a few examples. Okay, the absolute value of 5. What's that going to be? 5. So if we were to look at a number line, we'd be able to see that 5 is 5 away from 0.
Okay. What are the ones for you?
They're not ones. Those are the absolute value signs. Okay, next one. Absolute value of negative 7.
7.
Why is it 7?
Because it's the opposite of 0.
Yeah, if we were to count from 0, we would count 7 jumps or 7 whatevers to get to negative 7. So the absolute value is going to be 7.
So this can't be negative?
Absolute value, as far as I know, is not going to be negative. Because it's just talking about distance. So, you know, if you were to measure something, you wouldn't have a negative measurement. So it's kind of, you think about it in those terms. Okay? What about the absolute value of negative 6?
6.
Would be positive 6. Well, not positive 6, just 6. Okay? Because it's going to be 6 away from 0. What about absolute value of 10?
10.
It's going to be 10. Okay? That should be pretty simple.
Why is it positive when you write down the number? You have 5 and you want to get to 0. 1, 2, go negative 5, negative 4, negative 3, negative 2, negative 1, then 0.
But how many times did you jump?
5.
So that's your absolute value.
That
Okay?
has nothing to do with the number line.
It has everything to do with the number line. It's talking about the distance from 0. If you were to look at a number line and count how many jumps do you have to do to get to 5 or negative 5, you would count, and that would be your absolute value. Okay?
What if you're counting by a certain number of time? What if you only have a point at two numbers, like you get 2, 4, and 6? Maybe you get half of them?
Yeah, it'll be the same because you don't count and leave out those numbers in between to go from 0 to whatever number. So, any other questions? Okay, well we're going to go ahead and move into the next section because these are both pretty similar. They're pretty easy, so we're just going to push them together. So the next section, we're going to continue looking at integers. And we're going to be comparing integers, talking about less than or greater than. And we're also going to be ordering integers from least to greatest. Okay, so the first thing to remember is that we can use a number line. We can use a number line to compare integers. And when we're talking about comparing them, we're talking about, are they greater than or less than? Okay, so looking at this number line, let's go ahead and just label it, and we can use it to compare our integers. So on the right, what are we going to have?
Positive numbers.
They're going to be all positive. And on the left, they're all going to be negative. Why are they all negative?
Because they're lower than 0.
They're less than 0. Good. So numbers on the left side of the number line, are they going to be larger or smaller than numbers on the right?
Smaller.
They're going to be smaller because they're less than 0. So as you go further to the right, the numbers are going to get bigger. Okay? So let's look at a few examples. We're going to compare our integers, decide which one, or whether the first one is greater than or less than the second one. Okay? So A, we have -4 and 2. Is -4 greater than or less than 2?
Less.
It's going to be less than. And if you're not sure, you can find the two numbers on your number line, and obviously whichever one is on the right is going to be what?
Bigger.
It's going to be bigger. So -4 is going to be less than 2. Okay, what about -3 and -5?
Less than.
Is -3 greater than or less than -5?
Greater than 3.
Let's look at the number line.
Because it's closer to 0 than 5.
Exactly. Whichever one is going to be, with negative numbers, whichever one is closer to 0 is going to be greater. Okay? So -3 is going to be greater than -5. Right. For positive numbers, it's going to be the opposite. Whichever one is further away from 0 is going to be larger.
So basically the biggest one for positive.
Okay? What about 0 and -4? Which one is going to be greater? 0 is going to be greater than -4. Okay? Because obviously we know -4 is less than 0. Okay, what about -6 and -4? Which one is greater? Yeah, -4. What about 10 and 12? Which one's greater? 12 is going to be greater. Okay, what about -8 and -9? Which one is greater? -8. Okay? So that should be pretty simple. Okay, so now that we've gotten some practice comparing these integers, let's see how well we can do at putting them in order from least to greatest. Okay, this might be a little trickier, but you can use your number line to help you out. Okay? So the first one, we have 3 integers. We have 4, -2, and 1. And we want to order them from least to greatest. Okay, raise your hand if you can tell me which one is going to come first. Which is going to be the smallest integer we're going to put first? -2. You can even cross them out once you put them in order. What's going to come after -2? What's the next bigger number?
1.
And then what's going to be the greatest number? 4. Okay, so from least to greatest, we would go -2, then 1, then 4. Okay? If we were to look at our number line, we could check. As we go from left to right, that should be the order we hit these numbers. So there's -2, 1, and 4. So we did that right. Okay, let's look at the next one. We've got -2, 0, 2, and negative 5.
5.
Miller, what's going to come first? What's the smallest number we're working with? Yeah, negative 5 is going to go first. What's going to come next? Negative 2. After negative 2, it's going to be 0. And what's our greatest number? 2. Good. Okay, we've got 2 more sets of numbers. All right, this is a little bit longer set of numbers. Okay, we've got negative 7, 0, negative 5, negative 2, positive 1, negative 1, 4, 9, and 3. Okay, so we've got quite a few more integers we're working with. Okay? Now you getting this down? All right, so looking at all of those integers, which one is going to be the smallest number that we're going to put first? Yeah, I think negative 7 is going to come first. All right? What's going to come next? Negative 5. Okay. What's next, Damon? Negative 2. What's after that, Caleb? Negative 1. Okay. What comes next? Not quite. 0 is going to come next. Okay. Then after 0, positive 1. Then what's next? 3. And then 4. And what's our biggest number? 9. Okay? So we just ordered those from least to greatest. Okay? Questions on that before we look at our last example? Yeah. Yeah, with negative numbers, the smaller they are, the bigger the number. If you did the opposite way, you would be going from biggest to smallest. That would be going from greatest to least. They would just be swapping it. If the directions tell you to, yes. But if they say to go least to greatest, then that's what you need to do. They'll make sure you know. Okay? All right, last one. I've got negative 25, 100, negative 50, and 75. What's the smallest number I'm going to start with? Negative 50. Okay, what's next?
Negative 25.
Okay. 75 and 100. Okay, they're much further apart, but we can still put them in order from least to greatest. Okay? Any questions before we move on? Okay.